Hello, this is section 6.4, the normal approximation to the binomial distribution. So binomial distribution was need to be the fixed number to trial, and outcome each must be independent, and then only has two outcomes, and then probability of the success must remain the same as the each trial, which is all the success will be the same rate. So in order to find the mean, it's n times p, and then standard deviation is the square root of n times p times 1 minus p. So when n is a large, and that is 100 or more, normal distribution can be sometimes be used to approximate the binomial distribution. When the probability of the success close to 0.5, the shape of the binomial distribution is approximately normal. Statisticians agreed as a rule of the thumb that the normal distribution should be used only the n times p is greater equal to 5 or n times q is greater equal to 5. However, continuity correction should be used, the employing the normal distribution to represent the discrete distribution. So the continuity correction means that for any specific value of x, let's say 8, the boundary of x in the binomial distribution, in this case 7.5 or 8 prime must be used. So summary of the normal approximation to binomial distribution. So binomial, when finding as probability of x equal to a, probability x is greater equal to a or greater than a, less than equal to a or less than a as a normal that we're going to use as we actually subtract the 0.5 on, so this is the x that we are looking at, and then for the greater a minus 0.5, and then a so this is what we apply when we get to the problem. Okay, all right, so let's look at the next page. So procedure for the normal approximation to binomial distribution. So number one, check to see whether the normal approximation can be used. Number two, find the mean, which is mu and standard deviation sigma, and write the problem in probability notation using x like a p of x. And then step 4, rewrite the problem by using continuity correction factor and show the corresponding area under the normal distribution. And step 5, find the corresponding z values using the z table. And then the step 6, find the solutions. All right, so let's look at the problem. So population of the college cities. College students often make up a substantial portion of the population of the college cities and towns. State College, Pennsylvania, ranked first with 71.1% of the population made up of the college student. So this is kind of college town. What is the probability that the random sample of the 150 people from the state college, more than 90 or more college, more than 90 are not college student? So in the step 1, we need to check to the normal. We need to check to the normal approximation can be used. All right, so let's say P represent the probability a person in state college is not a college student. Thus, if the probability that a citizen is a college student, which is 0.711, the probability that a citizen is not a college student, you subtract the 0.711 from 1, which is going to be 0.289. So this number is from the 1 minus 0.711. Alright, so let's say n equal to 150. So they choose the 150 people, which is number is greater more than 100. And then p is 0.289 because we are looking for the number that is not a college student. And then NP is, so 150 times 0.289, which is 43.35, which is a greater equal to 5. Also NQ from the 150, and then subtract the number from the NP, which is 43.35, which equal to 106.65, which is a greater equal to 5. So we can say this is the normal distribution. Can be used. Alright, so that's step 1. So in step 2, we're going to find the mu and the standard deviation sigma. So find the mu is n times p, which is 150 times 0.289, which equal to 43.35. For the sigma, which is square root of n times p times 1 minus p, which is 150 times 0.289 times 1 minus 0.289, which equal to about 30.8218, and then approximately 5.552. So that's the sigma, so we might use later. All right, next page. Now in step 3, we need to write the probability notation that the model, the problem, what is the probability that in a random sample of the 150 people from the state college, more than 50 are not the college students. So we are looking for probability form. So we want to say more than 50 are not college students. So as a notation is we have to say x is greater than 50. And then step 4, we want to rewrite the problem using the continuity correction factor. So p of x is greater than 50 is same as p of x is greater 50 plus 0.5. And then we just says a p of x is greater than 50.5. Now in step 5, we need to find the corresponding the z-value, which is a z-score. So which is 50.5, which is x minus mu, which is 43.35 over sigma, which is a 5.552. And then simplify is about 1.29. Now, in the step 6, we're going to find the probability. Use the table E to find the probability, which is starting from the x is greater than as a probability 50.5, which is we convert to the z-score, which is greater than 1.29, which is the same as 1 minus p of z is less than 1.29. And then 1 minus z-score up to the 1.29 is 0.9015. And then the probability the greater than 50.5 is going to be 0.0985. So this is actually the percentage, which is about the 9.85%. All right, so that's all for the 6.4. Thank you for listening.